You know what's terrifying? There are likely over 100 million black holes in our Milky Way galaxy alone, and we can't even see them. These invisible giants swallow stars, bend space, and even trap light itself. And yet, the closest one? It's just 1,560 light-years from Earth. In cosmic terms, that's next door. We used to think black holes were just wild sci-fi ideas, but today we've taken real photos of them, studied their magnetic fields, and even recorded their collisions from billions of light-years away. This is everything you need to know about the universe's most mysterious monster, the black hole. Chapter 1. What exactly is a black hole? Let's start with the basics. But trust me, even the basics here are insane. A black hole is basically a region in space where gravity is so strong, nothing can escape. Not light, not time, not even information. Once you cross the boundary, called the event horizon, you're gone. No signal, no escape, just game over. And here's the craziest part. We used to think black holes were just theoretical, but now we know they're real, and they're everywhere. According to NASA, our Milky Way galaxy might be hiding over 100 million black holes. Yeah, that's not a typo. 100 million, and the closest one to Earth, Gaia BH1, is just 1,560 light-years away. In space terms, that's like being in the same cosmic neighborhood. But how do these monsters actually form? There are two main ways. The first is when a massive star dies. After burning through its fuel, the star collapses under its own gravity. If it's big enough, more than about 8 times the mass of our Sun, the core compresses so violently that it doesn't just become a neutron star, it becomes a black hole. This is called a stellar mass black hole, and it usually ends up with a mass a few times that of the Sun, but compressed into something the size of a city. Think about that. Something heavier than our Sun, packed into a space smaller than Manhattan. The second way? Even crazier. Some black holes form directly from gas clouds collapsing in the early universe, without even forming a star first. These can become massive, hundreds of thousands of times the mass of the Sun, and are thought to be the seeds of the supermassive black holes we now find at the center of galaxies. Like the one at the center of our own galaxy, Sagittarius A. This beast is about 4 million times the mass of the Sun, sitting 26,000 light-years away. It just chills there, quiet, dark, and incomprehensibly heavy. And then there's the black hole that truly changed the game, the one in M87, 55 million light-years away. In 2019, the Event Horizon Telescope captured the first actual image of it, a glowing orange ring surrounding a pitch-black center. That was the moment we went from black holes are real to here's what one actually looks like. And yeah, it's terrifying and beautiful at the same time. But black holes don't just sit there. They grow, they feed, they evolve. You've probably heard this theory, that black holes might be portals to another universe. Kinda like in the movie Interstellar, right? But here's the truth. As cool as that sounds, it's not how black holes work. A black hole is so powerful that not even light can escape it. So, how would anything, including you, come out the other side into a different place? Answer: you wouldn't. Once you're in, you're stuck. That's just physics. But here's where it gets interesting. There's something in theoretical physics called a white hole, basically the opposite of a black hole, where a black hole pulls everything in. A white hole throws everything out and nothing can enter it. So if, and this is a huge if, a black hole and a white hole were somehow connected, like two ends of a tunnel, then yeah, technically you could travel millions of kilometers in just minutes. That's what scientists call a wormhole, and it's one of the craziest ideas in modern physics. Want to see a full video breaking down white holes and how they might work? Let me know in the comments. I'll make it happen. And hey, If you're enjoying this video so far and appreciate the effort we put in, hit that subscribe button. It really helps us keep going. And in Chapter 2, we'll go deeper into the different types of black holes, how they behave, and why some of them might even hold the key to new physics, or maybe, just maybe, a bridge to somewhere else. Chapter 2. Not all black holes are the same. So now that you know what a black hole is and how it forms, let's blow the lid off something bigger. Not all black holes are created equal. First up, stellar black holes. These are the baby black holes, formed when massive stars collapse. They're small by cosmic standards, maybe 3 to 10 times the mass of our Sun. But don't be fooled by the size. They're insanely dense, and they pull in nearby gas, dust, even entire stars if they get too close. These stellar black holes are everywhere, scattered across our galaxy, mostly invisible unless they're feeding. That's when they start ripping apart nearby material, heating it up, and glowing in X-rays. And that's how astronomers actually spot them. One of the first ever discovered was Cygnus X1, found way back in 1964. It was the first real clue that black holes weren't just theory, they were actually out there. Next, supermassive black holes. These are the kings of black holes, millions, sometimes billions of times more massive than our Sun, and somehow they're not much bigger in size than a star. That means they're so dense, they bend space and time itself around them like a whirlpool in space-time. Every large galaxy, including ours, has one of these monsters at the center. Ours is called Sagittarius A, and we finally got a photo of it in 2022. But here's the mystery. No one really knows how supermassive black holes form. Some scientists think they grow slowly, starting as small black holes that merge over time. Others believe they formed from direct gas collapse early in the universe. There are even theories involving dark matter and stellar clusters falling in together. We don't have all the answers yet, but we're closer than ever to figuring it out. Then, intermediate black holes. These are the black hole middle children, too big to be stellar, too small to be supermassive. And for years, we weren't even sure they existed. But that changed in 2014 and again in 2021, when astronomers caught strong signs of intermediate mass black holes, including one detected using a gamma-ray burst. These elusive objects might be hiding in dwarf galaxies or scattered around the universe, and they could be the missing link in understanding black hole evolution. Finally, binary black holes. Double trouble. These are systems where two black holes orbit each other until they crash. And when they do, they send out gravitational waves, ripples in space-time that we can now detect thanks to instruments like LIGO. In 2015, we heard those waves for the first time. The universe literally shook, and that sound confirmed that black hole collisions are real. And here's where things get weird. In Chapter 3, we're diving into the mind-melting side of black holes. Do they really evaporate? Could they lead to other universes? And are they secretly wormholes? Chapter 3. Do black holes die or lead to another universe? So we've talked about what black holes are, how they form, and the different types out there. But now let's get into the really mind-bending stuff. First, do black holes die? Turns out, kinda. Back in the 1970s, legendary physicist Stephen Hawking dropped a theory that changed everything. Black holes can actually evaporate. Here's how it works. According to quantum theory, empty space isn't really empty. Tiny particles are constantly popping in and out of existence in pairs, a particle and an antiparticle. Usually, they appear, cancel each other out, and disappear in a flash. But if this happens right near the edge of a black hole, the event horizon, something strange can happen. One particle falls in, the other escapes. The one that escapes carries away a tiny bit of the black hole's energy. Over trillions and trillions of years, this slow leak, known as Hawking radiation, could cause the black hole to lose mass and eventually vanish. That's right, the scariest object in the universe might someday just fade out of existence. But don't worry, this takes longer than the age of the universe. Your selfie is safe. Now the fun part, are black holes wormholes? Short answer, no. But long answer, maybe. A wormhole is a theoretical tunnel through space-time, like a cosmic shortcut. Some scientists have speculated that the center of a black hole, called the singularity, might connect to another point in space, or even a different universe. Wild, right? This idea comes from Einstein's general theory of relativity, which describes how gravity bends space and time. The math allows for wormholes, but we've never seen one, and it's unclear if they could ever stay stable. Still, some believe that inside certain types of black holes, especially rotating ones, a wormhole-like structure could briefly exist. But to be clear, if you fall in, you're not warping to another galaxy like in Interstellar. You're getting spaghettified. And what's up with the singularity? That's the core, the place where a black hole's mass is crammed into a single point with infinite density. Yeah, infinite. It's where all known laws of physics just break. Time, space, matter, everything collapses. We don't fully understand what happens there, and that's why black holes are so exciting. They're not just mysterious, they're limits in our understanding of reality. Every time we observe them, like with the Event Horizon Telescope or LIGO's gravitational wave detectors, we're pushing science forward. So, the next time you look up at the night sky, just remember, there are invisible monsters out there, bending space and time, swallowing stars, and maybe, just maybe, hiding secrets we haven't even dreamed of yet.